Here we go. We have a question, smallest positive missing number. So you have given an integer array. Your task is to find the smallest positive number missing from the array. Note here is number start from 1 and the array can have negative number also. So in this case 1 is present, 2 is present, 3 is not present. So we got 3. In this case 1 present, 2 is there, 3 is there, 4 is not there. In this case 0, we don't start from 0, we start from 1. So 1 is not there. So that's about the problem description. Let's try to build this. So we have this. So in this, negative number will make no sense to us. We are only interested in the positive numbers. So we will only consider the positive numbers. So if we iterate first time and if we find any negative number, we will convert into infinity, positive infinity. We will convert into positive infinity. Next, on the second iteration, actually I don't have 0, so let me add that case also. So in this case we also have 0. We have to handle this case. So then we start. We got this number. So what it means is we have 5. We have 5. So we have to somehow remember that we have 5. And here we have 1. We need to somehow remember that we have 1. One approach will be to use set, but I will not gonna use any space. I will just mark in the same array itself. So if I got 1, I will mark this position because this position will represent there's a 1, there's a 2, there's a 3, there's a 4. But we will not change the number. We will not swap the numbers. We will just need to mark the number itself. So let me change the color. If we got 5, the 5 position will be here. It will be 1, then 2, then 3, then 4, then 5. So it will be index minus 1 position. So we got 5. 5 minus 1 will be 4. So we need to mark this position. So I will just convert into negative number. I will mark this number, this position with negative sign. Next we got 7. So I will change number minus 1 index. So 7 means 6 index. So I will change this number to negative. Then we got 2. So number minus 1. So I will change this number. Next we got 9. So number minus 1 index. So I will change this. It will be minus infinity. Then we got this. We have minus 8. But we need positive 8 to mark next position. So we are at a ith position and we will first do the absolute of the current element. Then instead of minus 8 we got 8, and for 8 as you already know we have to mark 7th position. Next we got 1, so we need to mark this position. Next we got 1, so we need to mark this position. This is already marked, so we don't need to do anything. We need to just convert the position with negative number. So how we will check? This will mark that index. So the code will be, first of all, value, or let's say id. Id will be absolute of arr of ith. So we got 1. Then we need to change this position. So what I can do is I will just subtract minus 1 to get the index. Next, for the index I will convert into this but it will give me wrong answer on the next time. Suppose we got this, so it will give me id as 0. If I convert, initially the number is 5, if I convert into -5 it will do the work, but if I have this number, then absolute, we got positive 1, then if I subtract -1 we got 0, so we need to mark this position. So we have this position, so we uh, we got this, but we don't want this, we want -5 itself, we want -5 itself. So one thing you can do is absolute of this number, absolute of this number, ARR of ID. If it is negative, it will first convert into positive, then it will mark as negative. If it is already positive, then we can simply convert into negative. So this will do the work if there's duplicacy. So we have done till now, so then we got 6. For 6 I will mark fifth position. For this number, this is out of bound, so before doing this we need to first check, we got this id, then before doing this, operation, this step, we need to check if id is, less than or equal to 0 and id is less than n, then only do this step, so this is invalid, this is invalid, this is invalid. Then we got 4, it will mark this position. Then we got 3, it will mark this position. Then we got 10, it will mark this position. Then we got 0, so it will be 0, then -1, so we got -1, it is invalid, so we don't have to do anything. Then on the next iteration, so let me write the steps here. First iteration will be to change negative negative values, will be converted into positive infinity. On the next iteration, we need to mark the indices. On the third iteration, let's do the third iteration. So we have minus value here, means in the array, somewhere in the array we have 1, yes. This position is also negative, means somewhere in the array we have 2 also. This position is also negative, means somewhere in the array we have 3 also. This position is also negative, means somewhere in the array we have 4 also. This position is also negative, means somewhere in the array we have 5 also. This position is also negative, we have 6 also. This position is also negative, we have 7 also. This is also negative, we have 8. Also negative, we have 9. Also negative, we have 10. Also negative note, we have positive. If a positive value is found, so we need to find positive value. And if positive value is found, we need to return I plus 1. So this position is negative, which means we have 10 here. This position is positive, means we don't have 11, number 11. As you can see in the array, we don't have number 11. If we have positive number, just return I plus 1. So let's talk about a special test case. So let me remove this. So suppose we have this, and let's also write the indices. Then we got this number. So first we have to convert into positive. So we got 1. 1 minus 1 is 0. 1 minus 1 is 0. So I will mark this position. Then we have 2. 2 minus 1 is 1. We need to mark this position. 3 minus 1 is 2. We need to mark this position. 5 minus 1 is 4. We need to mark this position. 4 minus 1 is 3. We need to mark this position. Then we have done this step. We have done this step. We are into this step. So is the number negative? Is the number positive? No. Number is not positive. Number is not positive. Negative, negative. So if no number is found, we need to return n plus 1, which means we have in the array 1, we have 2 also in the array, we have 3 also, we have 4 also. That's how this number is negative. That's why this number is negative. We have 5 also, but we don't have 6. So we need to just return n plus 1. So that's how this approach will work. Let's try to code this. So what we got n, then we are doing first iteration. If the number is negative, just mark it with a positive infinity. Then on the second iteration, first get the number. Then if the number is greater than 0 or less than equal to n, then we need to find the index. Index will be current minus 1. Then we need to mark the index. After marking the index, we are on to third iteration. If the number is positive, means this current I plus 1th value is not present. That's why ith index is not marked. If all values are negative in the array, then we don't have n plus 1. So let's give it a try, and let's talk about time and space complexity. In this code, it is pretty clear the time complexity is order of n. Space complexity is constant. Code is given in the description box. If you guys have any doubt, feel free to ask in the comment section. And thank you all for watching.